Hello, calculus scholars. This weekend, you're going to be learning another rule of taking derivatives, and this rule is called the chain rule. And I always like to begin chain rule with a little meme. This says, "Yo, dog, I heard you put functions, so we put a function in your function so you can derive while you derive." So there's this function in your function. So that's kind of a token word for composition of functions. So what we mean by that is back like in Algebra 2 days, you did like composition of functions. And, let's say, for instance, that I have f of g of x. So what that means is I have a -3 times, and I'm just going to put in parentheses for x, but I'm going to be putting the g of x stuff in a little bit later, plus 7. This is -3x plus 7. That was your f of x. Now, the g of x, I'll kind of like make like the green function for this. So we put the 2x squared minus 8. And one of the things that I'm actually going to have you do on Delta Math is just get a lot of practice being in the mindset of the composition of functions, because it's going to help you a little bit better about seeing what is the inner function and what is the outer function. So we kind of refer to, our g of x case as being the inner function. And then our f of x case being the outer function. Now let's say we kind of go the other way around, and I'm just going to kind of show you another composition notation here. So what this really is on number 11 is we're doing g of f of x. So the outer and the inner become, kind of mixed up. So what I would do, kind of in this case, so I got 2 times the x squared minus 8, and I'm going to put the actual f of x in. My f of x is -3x plus 7. So these are, kind of how we do the function compositions, just to kind of give you a refresher course here. All right, so let's actually kind of apply this now to some calculus. So I'm going to kind of show you some functions without the chain rule that you would take the derivative with. So we already know how to take these derivatives. And then these functions, you are required to take the chain rule. And we're going to kind of, in the first exercise, just show you how to get a good setup for the chain rule. This is the technical definition of the chain rule. So there's a lot of like different notations that are used. So these are some examples that you will see in calculus textbooks. So the dy dx notation you see sometimes, or like the f of g of x notation. So like this is f prime g in shorthand times g of x. So like what this says is you take the derivative of the outside putting in the inner times the derivative of the inside. One thing that I think is actually kind of helpful, I know that these rules are kind of a little bit dense, but one thing that we can kind of see is helpful is if we look at kind of like this first example here, this just kind of helps us think about, what is the inside versus what is the outside. So what we're going to practice here is we're just going to look at the inside of the function. So this is the inner function. So our inner function is 2x minus 1 on this one. And then on this column, we write the function in terms of u. So what I mean by that is I write this as 3u squared. All right, now on this one, when we have denominators, that's kind of like the inner function here. So our u is x plus 1. And then our y would just be 1 over u. When you have a trig function, your inner function, so when I say sine of, the of is the buzzword for what your u is going to be. So our u is equal to 2x. So we would write this as y equals to sine of u. And then last but not least, when we have stuff that radicals, what is inside of a radical is always going to be your inner function. So then I would just write this as y equals to square root of u. And what you'll notice here is that these are actually a lot easier to do, to take derivatives of. So now let's actually go through the steps to doing a chain rule in practice. This is actually kind of something that I had in a PowerPoint from last year. So this is please work in your seats. Obviously, we're not working in our seats right now. But what I would like to kind of see in a good chain rule calculation is that you are identifying your u, then you are taking the derivative of your u as well. So you should have u equals and then du equals, so that's the derivative of your u. And then have an expression in terms of u, and then write your final answer in terms of x. So what this means is that after you have your u expression, rewrite in terms of x. Okay, let's take a look at an example now. You could, if you wanted to, like multiply 3 times, but it's going to take a lot longer. If you know the chain rule really well, it's actually going to be very, very quick. So what we have here, what we want to do first is we write what our u is. So our u is what is inside of a parentheses, and then our du is going to be just the derivative of what we just wrote. That's 2x. So these are the first ingredients towards finding success. Now, if I'm taking the derivative what I'm going to do is I'm going to write my y in terms of u. This is y equals to u cubed, where u just coming from. So if I actually put in for that u, I would have the x squared plus 1 to the third power. Now, if I'm taking the derivative, we do 3u squared times du. So we include this du to kind of let us know that we have taken the derivative. And this is actually kind of like the derivative of the inside. And then we just substitute. So I have 3, and then my u is just x squared plus 1. And then my du is 2x. And we just put in our expression with x's in. And then my du just comes from the fact that my du, my derivative, was 2x. So what this says is that you take the derivative of the outside, leaving the inside alone, times the derivative of the inside. So usually what I often find with my students is the first few times with chain rule, it does appear a little bit confusing, but I would encourage you is that as we kind of look through these examples and we get in that composition of function mindset, to really look for some patterns, and you'll be able to pick up the chain rule that way. And we're going to be spreading the chain rule over 2 days and kind of like introduce the varying difficulty levels as well. All right, let's do another one. So here, I'm going to write my u. My u is what is inside of the parentheses. And then my du is going to be 3 minus 4x. So then I'm going to take my derivative. Well, I want to make sure that I'm writing this in terms of u first. So this is y equals to u cubed. So the whole premise of the chain rule is that you are rewriting the function into an easier, more kind of like bird's eye view way, and kind of worrying about like kind of the outer function rule first, and then worrying about like kind of the nitty gritty stuff inside of the parentheses. Now, when we're taking the derivative, I'm just going to kind of use the y prime notation here, even though it is asking for dy dx. I mean, y prime and dy dx mean the same thing. So I'm going to say that this is 3u squared times du. And we substitute in our u. So this is going to be 3 times 3x minus 2x squared times my du, which is negative 4x. And that is the chain rule completely done. Now, chain rule really has its beauty when you get to things like radicals and stuff like that. So let's look at some big, bad radicals, will ya? So for this one, what I would do kind of initially first, I would still do my u. This is actually kind of like a meta chain rule, if you ask me. So I would, on this one, I'm actually going to include everything that is inside of the radicals. This one, polynomial multiplication isn't too bad. So I may just do that. Get x to the fourth minus 2x squared plus 1. And then my du would be just, when I take the derivative of that, the 4x to the third minus 4x. And the plus 1 goes away. So you could actually do the chain rule and get slightly different form. This is actually kind of like a chain rule within a chain rule. But I just want you to kind of have the experience of just worrying about the radical and the function inside. So what this function is really going on, this is really just like the third root of u. Then I'm going to write my y, just going to write this as a fractional exponent, so it's u to the 1/3. So if I'm taking the derivative of this, this is going to be 1/3 u to the negative 2/3 du. And I'm just going to put this like kind of in the numerator and the denominator. So the 1 goes in the numerator and the du goes in the numerator. And then in the denominator, I have a 3. And then this is u to the 2/3. And I'm going to put it in like radical form. So this would be 3u squared du. And then I just substitute everything back in. So my du is just going to be 4x cubed minus 4x. And then on the bottom here, I will have the third root of u squared. So I have x to the 4th minus 2x squared plus 1 all squared. Now this is probably about as difficult as we would get. A lot of going on, you know, with this chain rule here. All right, and then C, this is kind of a case of where you have, I think it's pretty easy to see what the inner function is, so we'll just take care of that. And then our du is just 2. But what I would do is I would write this as y equals to negative 7 over u squared. And I'll write this kind of in like a power rule type of format here. So when we do this, I get, when I take the derivative, I get 14 u to the negative 3rd du. And I'm going to write this as 14 over u cubed du. And lo and behold, we get 14 over 2x minus 3 to the 3rd times du. This would be 28 over 2x minus 3 to the 3rd. Woo! So chain rule really does have its merits, you know, when you get into like these really ugly looking things with like these fractions, functions within functions. And this actually saved us a little time, and we didn't have to go and do like, you know, that quotient rule type of thing. So I think that's enough for today. Just one more thing. Just kind of like one more example. Let's say we'll just kind of go back to the level. Let's say I have, you know, 5 times x squared plus 2 to the 60th. Now, what some people become very skilled at doing is just kind of recognize the pattern. So they say, okay, I'm going to take the derivative of the outside. So they know to do, let's see, this is 300. They leave the inside alone and they put this as 59. And then they take the derivative of the inside. So some people who are really natural at this chain rule, kind of notice that pattern. We'll just call this example part D. So please reach out if you have any questions on this one. Chain rule is kind of the more difficult one, I would say, of the 4 major derivative rules. But we usually use chain rule in situations where you have trig functions, like if I say sine of, square root of, anything that has like, things in parentheses. So these type of situations, radical situations, square root type of situations, trig type of situations. This is where we kind of see a lot of the chain rule. So I hope everybody has a good weekend, and we'll see you next week.